Okay, so last time we have did some experiments with networking and learned how to do that, and before that we had our Qt project which allowed us to plot things, so it might be a good idea to try to mix those two skills together and create some application that would receive data over network and then plot them. So this is our old implementation. We could of course create a new project, or we continue modifying this one. I think we just create a new project and then copy whatever we need from this project over, and let's see how fast this goes. So I just quickly check where we saved this, since I want to have the same path to the library which we need. So we'll in this project also need the QWT library, so we have a subfolder for that. We first started the QWidget application, so with widgets, and we call it data panel. So we need to add networking. The rest can remain as is. We just enable precompiled headers. So I think last time we actually did not really use the precompiled header file a lot. We have not added anything, so we can take a short overview of what various includes we need, but we didn't really need many. We used QApplication and QMainWindow, and QWidget is included. So what we can do is we can add all the includes we need this time to our header file, at least for standard includes. For the QWT we'll still use manual including them whenever we need them. And this one, so then it doesn't need to be included here and there. Okay, and the idea is that we'll have like a main view where we have our plot, and somewhere on the side or on the bottom we will see where it looks the best. We'll place a list where we can add devices, and the devices will be communicating over network with other projects that we will create, which will just deliver data, and there we can implement this in a few ways, so that we can demonstrate a few different strategies how communication in such scenarios can be implemented best. I see we have one more. Okay, so one thing we could do this time differently is, in this project we have used this Qt designer to actually place things around, and instead of that we can go the manual route and create the UI by hand. So we can delete this form file and this and this and that, and we start manually. So we'll need various includes, so I'll just keep that on the side so I can add them easily without changing the views whenever I need. So a useful main layout for a project is using a QGrid layout, as it gives us the most flexibility. And it will contain the plot, so else do we need? We will have a list, so Q3 widget. So Qt offers a whole set of different objects which can be used to visualize lists, like a QList or a Qtable, but also a Q3 widget. The Q3 widget is a bit more complex, as it also allows to show hierarchical data in form of trees. But its main advantage over a simple list widget is that it allows to use multiple columns while not being so cluttered optically like a Qtable. So we will use here a Q3 widget with only one level of hierarchy, although we might decide to add additional levels later. For example, if we would change the system such that one device would be able to provide more than one data stream, which is a natural extension. So whenever you have any sort of list, so I can demo here another Qt project. So for example, this program here, it has, as you see, a lot of lists, but everywhere it uses this Q3 widget, even though it is not structured like a tree. Or this view here, it's just a list, but it can be switched into a tree, so that now it's hierarchical. Now again, it's just a flat list. So generally, I always go for using this Q3 widget, although there is one thing to keep in mind. You can have a Q3 widget and a Q3 view. The difference is the view is like a more abstract object, and you need to provide to it a self-written data model. The Q3 widget comes with a basic data model that you can use, and it's quite convenient. The main downside is that it's much more computationally intensive if you would have very large sets of data. So again, with this project here, if you have a few hundred lines, actually this is not even that much, you can switch the file view, which once it loads will contain a list of all the open files on the system, and effectively this would not be efficient with a Q3 widget. So in this case, this is the things. Most of the views here are implemented using tree views with a custom model which is optimized for large data sets. Okay, so we use this thing. Then we will of course need a few buttons so that we can add and remove devices. So Q tool button and remove device or delete device. And for starters, well, yeah, we need probably a start and a stop button so that we can start, stop, and also a clear button for the data acquisition. So those will be more around the plot area located. So, and reset. Okay. And we need to find a reasonable layout. So the main plot of course will be in the middle, and I think the devices, since the way they are structured is they will be narrow. So you have the device name, you may be able to open the device later to have a channel or so, but this the way it works, it will not take a lot of vertical space, but horizontal you can add many devices. So we'll put the plot next to it, and I just thought of one more thing, to put the reset start stop things into the toolbar. This will allow us to use also this toolbar element. For now, nothing is complaining about missing includes, so we'll see whether that compiles nicely, or else we will need to add some includes here. Let's quickly see. Yeah, and for now it's fine. Okay, so let's start in our panel. Put this here on the side so that we where's the mouse? There is the mouse. The mouse switched to the cursor, so I didn't see it for a second. So first, of course, we need to initialize our grid layout, And we could of course improve the whole thing by actually having the ability to move the space, so like here, to have a spacer between the plot. But I think for now we'll just use the grid layout as is without this splitter, since it complicates things a bit. So this is set layout. Zack. Okay, then toolbar. New toolbar, and this goes then into the first row of the layout. So add widget, which widget, and then we can specify row, column, or if we go further down we can specify row, column, and how many rows or columns it should span. So of course row and column for the toolbar will be 0. Row span will be 1, since it only takes one row. But for columns we will specify 2 or even more, because we will of course have the the one panel with the plot and the one panel with the devices, and below the panel with the devices we will add the buttons to add and remove devices. So we either need to allocate sufficiently more columns and rows, or what we also could do is that we put another layout into the first layout, and then this way fill out the cells. So this is the strategy we'll try to implement now. Okay, so we have our toolbar, which doesn't have yet many buttons, so let's start with that. We could also use the add action. We don't necessarily need to create a custom tool button. Tool button would be added by add widget. But we could have actually really simplified that. For now, let's stick to how we started. We have our toolbar. Now for the plot to work we need a few includes, and since we already put a lot of work here, we can really just go for and copy the whole thing that we've created, and then this saves us a lot of work. We need to configure the include directories again. For later we remember we need to add a linker input as well, otherwise it will not compile. Okay, now all the includes are working and we can copy the initialization till here. Okay, so main layout, add widget again. Now we need to remember where to put it, so it will be row 1, column 0, and for now Okay, and now column span, sorry, row span will be 2, column span will be 1. Okay, let's quickly run it to see if it starts looking already correctly. Right, this we had from before, we don't need that. And of course we need the DLL, you can just copy it from the other project. Okay. Some of the Qt widgets behave slightly differently. They need a an explicit widget. So that setting the layout doesn't work directly. I've always forgot which one requires it and which one doesn't. But it's a quick fix. So as you see, so we have here our toolbar buttons and then the plot. There is nothing on the side as we haven't added this part yet. So let's do that. Okay, so it will be adjacent to the plot, so it will be also 1, and this will be 1. And this will really just take one cell and one row, so we don't need to span anything. Okay, as we see, there is still some space at the bottom where the buttons to add and remove will come in. So for those we will add Q. No, but then we're going to the widget, and here no, we need a widget for that as well. And where do we put it? Row 1, no, row 2, column 1, that should be all. Let's see where that ended up, where it should be. Right. Okay, so it's not quite ideal, but already looks quite nice, so we can adapt a few things. Content margins. and set spacing. Okay, that looks already much nicer. And we should limit the width that the tree view can take, so that this is fixed. Let's say 100. Will probably not be enough. Let's go with 200. Yeah. So you see, when it's getting smaller, but when it's getting bigger, it is limited in size. Okay. So now what we want is a class which will keep track of all the devices which we have added. And then we'll need a class which will represent individual devices. And for later use, we will implement it such that devices will be, so the class that represents devices will be an abstract class. It will be shared amongst many device subclasses, which each will be implemented in its own way, but such that through the interface of the general device class, we will be able to always get the data we need to plot them. And we should, from the get-go, design it such that we will support multiple channels, even though initially we will only allow to handle one channel for per device for simplicity. So let's add C device manager. Can be a queue object. We don't expect to have a large amount of computation, so we don't need to put it into a thread or something. And what also is good, I don't like all the things being like spread around. So instead of using the source and header directory, I always make an own filter, one for the GUI and one for the rest, for the core, and then that's it, and then put all my classes there so that the files are together. The practice of putting headers and sources completely somewhere else is from the time of the very old normal C, where you usually did not have the same amount of headers as C++ files, so usually you had like one header with many includes, and then for every more complex function you had an own C file. But here that we are using classes, it really is much more comfortable to have them in one place, because they are always related to each other, and you always need to modify, or at least often need to modify both. Okay, and the next thing will be of course our abstract device. We'll just call it C device. So let's add the device manager to our main UI. It needs a place to live, so to say. Another approach would be to create a Soliton class which would represent all the core components, but since here the whole thing is made around the UI, it's fine to have those elements somewhere on the UI. Okay, and what we can copy from the other project will be the timer. I'm not sure whether we will use it a lot, but oh, we already used the devices name. Let's call it device true. Okay. So this is ready. And now we will need to add some functionality to the buttons. That's working. Okay. So as said, we will implement it such that we will have different devices to choose from. So we will need to find a way how we elegantly represent this in the UI. So for example, we could add a window which will present a combo box where we can select from a list of devices and then provide some device properties. So for this we will create a new window. A device window, it will be derived from Q dialog. Okay. Okay. The type of someone is complaining about something. So the QMain window requires us to set a widget on it, on which then we can set the layout, but the QDialog seems to be just fine with setting the view directly. And what we'll use here will be a different sort of layout, QForm layout. I will call it main layout, and we'll have a Q combo box and device, and the rest that will be in the form we will populate it dynamically from the device. So if we have a device which communicates over the network, we would have two fields, one for the IP address and one for the port. If we have a device that uses serial, which in this case we will not implement because we do it only in software, we don't have a hardware to talk to, but then it would have serial port number, then baud rate, and so on and so on. And we can extend it later on that we would not only need to provide the IP and port, but also the protocol, which might be TCP, UDP, or something self-made, which would be based on UDP. So generally this can be quite flexible, and of course if we add more device types, then with some very custom devices we might need to specify other parameters. One common use case which you might experience in your own work in future is if you want to interface to some National Instrument devices, they would need a device path as an identifier with which hardware component to communicate. So yeah, that's just as much for a simple example of what other things might be needed. Since those things in the list will change depending on which device is selected, we should make a list of widgets. So that we can quickly clean up whenever we switch from one device in the drop-down list to the next. Okay, so initialize those two, and the rest will be initialized later. We also need to find a way to generate the list of devices, and we'll need and we also need at least for later means to also be able to create a device list based on external components. So there are two approaches. Generally one would be that you have your main application and you're just adding classes as you add devices, and each time something changes you just need to rebuild the whole project. But you could also structure your project such that you would use DLLs, so that for every device you would just create a new DLL, and then you would not need to recompile the whole project. Respectively, you could have a running system, and then you could just add a new device without even restarting the main program, just by adding a new DLL and reloading the device DLL folder. From here, since we want to keep things simple, we will just make this statically all in one program, but it would not be too difficult to break this up into an approach where we can really have independent DLLs, one for every device that we are using. Okay, so we have initialized this, we need to initialize that, can add that, set widget row 0 which role, I don't remember the row. There are 3 rows, label, field, and 1 is spanning row. As row spanning means that it will, so the form layout gives you a form, so it gives you labels on one side and then values on the other side. And if you use a spanning row, then you will have an entry for both of them. And I think it's nice to select the devices if this is like spanning both fields. Also, what we can do is we could add actually a label field on top of that. Actually, this would be then 1, this would be 0, and also as a helper we can add a row counter so that we know where we are, and we don't need to, and we can easily then reshuffle things. We need to fill in the devices, but we will do this later. For now, I'll just add a dummy list. Just have something in the view to show. We have the 3 devices and not yet any functionality. We will build this up step by step. So I copy the include here since we need this there. Okay, so we have our add device. So here create an instance of our window, just window, and to run exec on it. Exec is will open the window and it will lock until the window is closed. So we'll arrive at the next line only once we have closed the window. If we would use window show, then it would be shown in a non-modal way, meaning that then the rest of the application would instantly continue. Here we will add later a code to actually add the device. So the thing here is only supposed to return to us configurations. Although we could, if we would want it, change it such that it would also return us an already created device object. But I think it's better to just give the configuration, which will then pass further. So we are missing one more thing that we can add before we add many things. A Q button bar. That needs to be included. The button bar, I think it was called the button bar. There is a widget which provides you basically a bar with the OK and cancel button, and this it wasn't called the button bar. It's called a Q dialog button box. Okay, then Q dialog button box. Oops. can specify what orientation on buttons we want. So in principle we want a with a cancel and with an OK button, and that's I think already it. We don't need or want anything extra, and we only need to connect it with the current window. Buttons, comma accepted. So this is okay. This is and if you would add like a yes, no, or any other form of positive and negative buttons, they all map to this accepted and rejected slots. However, there can also be added custom buttons, in which case we would need to listen for a different signal. There is a clicked slot which gives you the button which was clicked exactly. So that's that. And one more thing we can do here, we can check if this is true. If this is not true, then return. So if we press on OK, then this thing will return 1, and if we press on cancel, then the dialog will return 0. Right. Okay, so if we do add, we forgot to add the button bar to our layout. So now that I think about it, the form layout is maybe not the best choice for the button bar. Optically that might not be ideal. So let's quickly, I mean, we can take a look how this will look, but I think it will not be great, because as you see it stays at the top, and we would rather want this to stay at the bottom. So as you see, cancel returns, and if we okay, then we go to the other case. So this works. So here we can improve that by using a QVBox layout. And this will be then the main layout, and that one will be then the form layout. Form layout, and then we will need a form widget for here, I guess. We can check what we can add, what types we can add, or we can add another layout. Actually, that should be fine. We don't need a widget. So let's stick with this, and then so this will be a FowBox layout. And we need to create, and this will be form layout. This will be again main layout. This is fine, but then it only takes the button bar, and then of course we'll need that item, but widget buttons, and here if we have our forms and layout, it will be the we didn't create it. Oops. We might still need a space, but let's see. So this already works without a space, fine, and we don't need to change anything. And so we could change the separation of the items if you would want to, but that looks fine as is, so we can leave it this way. Okay, so next step will be to get a device list so that we can replace this line, and then once something is selected from the combo box, a method to populate the form with additional fields. So what we will do here, we will include the main thing, since we will need to access here internally the device manager, and here we can add a function to get pointer on the device manager. And we of course then need the device manager also, so that we can interact with it. And one thing that is missing is we need a way to address this. So when we look to main, this created the panel on here locally, which is not ideal. So we'll create how do we call it? Let's be lazy with the name inventing. Just G for global, and in the construct, and we of course need to make this live somewhere. For example here, replace it with null, and here we assign it this, and just for completeness in the destructor we will assign it null, such that we are on the safe side. If we start deleting the element and things become not longer consistent, then we rather crash cleanly than trying to access something that doesn't longer exist. So G devices get list we will need to add, it doesn't exist yet. Also we should differentiate between a list of devices which have been added and devices which are available. So maybe get a list should be more specific in the name, so we could call it get available list, and the other one we could call installed list, or we call the other one just get list, and the other one or get inventory or something like that. What's a good name? Get available devices. That sounds good. And this will give us data pairs. So device manager. We can either use QPair to just use data pairs, or we create an own data type. I think this is more convenient. Available device. QString name. And QString ID. Paste. The idea is that the name can be something human readable, while the ID will be a short ID, maybe not a number, but like something 8 characters or below, that is just unique enough to identify the device, but is not like a nice long name that you would prefer to view in the UI. And here for starters we just return a empty list. command. We can set the data as ID. Okay, we'll just make it more compact. And we'll need to add a connect the combo box to some connect the combo box to some slot, so that once we select something there, then we see what was selected. So let's add a slot void on device and combo box current index changed. I should add here an index. Okay. So before we can continue here, we actually need to return some list. So for status, let's create a subfolder and then add a device. So let's demo device should be derived from C device. Okay. And here we will need to make a list of all the available device types. Since it is in the same project, we cannot easily enumerate the things, as C++ is generally lacking the ability of reflection that you might know from other languages like C#. So here we will just create a simple list. Actually, when I think about it, we don't need a body for the function. We'll just create a list here and add entries. M list. Okay, and we'll add a function enum devices, which will call from here once we have created it. But the function as set will only statically add the devices that we have in the project, so it will not in any way dynamically enumerate what there is available. Okay, and let's see what the device needs. So the devices need area. String get name and get ID. Oh, I mistyped here. so here we need to include that. And the annoying thing is that we need actually an instance of it in order to access the virtual functions here. So although we could simplify it, we can simplify it, we can do it differently. We can make a static function that will do the same thing, just with a just return those whenever we need, and from the other function we can then refer to the static versions. And of course static ist Punkt append s. Okay, so now when we run, we should have the device in the drop down list, and then we can continue with the arguments. Something's not right. Isn't that initialized? Oh, our G is 0, that's not fine. G is set to this, and there it is set as extern. Oh, I slipped by a few lines. This was supposed to go there. And we already have the demo device. We could then of course add a few more demo devices. So let's do that. But we will do it in a more demo device. Let's call the other one test device. Oops. I clicked too fast. Okay. Okay. Need to add this as well. Cool, then we will have 2 in the list, so we don't need to test that. We can be sure that this will work. So the next step will be to generate a list of parameters which can be set, and this can be done in principle arbitrarily complicated, because in the simplest way we'll just have a list of edit lines, so you can just type some text into each of them, based on the label, or we create or we make it such that you can select whether you want an edit line, a combo box, if a combo box, then with which values, or a checkbox, and so on and so on. I think to make it quick, we will design it such that we later can extend it to have all the different types, but for now we'll just start with a simple combo box. So go to a device template and create a helper class or construct, in this case as form field. Put in a label, and then we could add type values, etc. But for start, we will only use a QLabel. So that will be simple enough, and later we will extend this by adding here additional entries. So, alright, we of course need a function that will give us the next, which will q list form fields get form fields. Now both devices, the demo device and the test device, need to get such an entry. So this gives us the same problem we had before, that in principle it needs to be static, so actually we can remove it here because I don't expect that complicates things a bit, because this at this level needs to be so the complication is that if you want to implement the whole thing nicely, we will need to have an object for every device, such that we really can use the virtual functions properly. But the idea was initially that each device would only be created once we actually create it. So we either create a device prototype class, which will contain all this information. So every device would then come with two classes. One would be such a prototype class, which will help with managing what can be added, and another one would be an actual implementation. The other option, of course, is that we just query the manager, which will in a simple way just address the different static entries and get us the list from there. So this would also be an option, but it would not be so elegant. But we'll need it for the creation. Once it's created, we don't really need to do anything else. Yeah, let's still go with having two two objects, even though it complicates things. So we will move those things as a device prototype. We'll do it as a structure, as we don't need any more complex functionality. We need to do this. We could improve that. Let's maybe do it a bit more complicated. Let's go with device prototype. we will initialize the list in the constructor of every of the other objects. This is already defined. This we don't need because this will just take the list, and here in the constructor and yeah, that in the end I think it's more elegant this way. I have another idea. We can change the naming scheme a bit. This will allow us to use the factoid pattern for creating new devices, so this actually is a nice improvement. So here this will be a list of device factory pointers. Is be also simplified.append demo device factory. Type of device factory, that should be fine. But I don't think this will be the main issue. So the TR can only be used in things which are derived from QObject. We can outside in principle use since the TR is static, just QObject double point TR, but for now let's just ignore that. Complaining. We are missing this. I didn't adapt the names correctly. Now here as well. Now it should be fine. Yeah. And of course the second one is test device factory. Nice. Good. So this is done. But now we of course need to adapt our device vendor here. Since eval devices has changed, let's include just the device hash. Name, ID, okay, and we will need a few more improvements. So we will also need to be able to retrieve a single instance, or we could also just rename this to get factories. This should also be renamed. Let's just leave it at least for now. So this is here, and now so this will not be a list, but q map, q string, comma right, and this will return at ID value ID. Okay, so this needs to be changed slightly. This, when we are here, we have the index, so we can check. Well, we have to do everything first. In case there were some of the entries, we already need to clear them. So that we already started the clear. If you went from devices, item data at 15, user role, q string ID to string. Get factory by ID, and this should always give us a result, but we should check whether it worked, and if it failed, then we return just to be on the safe side. Okay, and if you have the factory, now we can get form fields, or better yet, auto reference form field and form fields. Okay, we will need a counter, and is gleich 1. I think it should be 2. We already used, yeah, 0 and 1 we already used, so we always start at 2. And we need our form layout. So form layout, add widget. Set widget should be widget row, comma, then we will use the label role. The label text from the field, the label, comma, okay, and we need to edit this should not be a pair, it's just a list. Widgets.append label. We will repeat the thing, but with a line edit. This does not have anything, although we could add one and row plus plus. We could improve the whole thing by adding here another string, so we can have a set placeholder text, which is like a gray text which is displayed as long as the field is empty. So we put the hint there, although we don't fill it yet. Since for the demo device it doesn't really make sense, but when we later add a network device, then we would write down like IP double point port or something like that to indicate in which format the data are expected. Okay, so but this is of course a bit boring, so let's improve it quickly by making the test device have more fields than the demo device. 2, 2, 2, 2, 3, 3, 3, 3. Oops, 3. So one device has one field and the other device has 3 fields. So we should see when we not working. Wait, there was only one. There seems to be a typo in our device manager. Enum test test device. The demo device has the wrong ID. Since we stored them in a map, if we would have 2 devices with the same ID, the other one will be overwritten. So this. Okay, this failed spectacularly. Also, another issue is that we should probably have like a dummy entry so that we always trigger the device selection. So let's improve on that. We'll add here an item which will be in fact empty. Yeah. And the question is, why did this didn't work? So we have our loop. We should have added a couple elements, and then okay, this should not be labeled. There should be field role. I don't think this will solve the issue, but let's try it again. Okay, no, it works. So it really was just that we assigned the same widget. Oh yeah, and we of course forgot to clear it afterwards. You see, it works great. Of course it's slightly limited, so we should also maybe disable the OK button until we have something selected. Button OK. Set enable false, and here set enable factory ungleich null. So if we select an empty entry, then it won't do anything, and it will not allow us to press OK. If we select any other entry, then it will be fine. So as you see, it's disabled. When we select demo, then we can press OK. If we select test, we can also press OK. If we select nothing, we cannot press anything. In principle, we could also change it such that the first entry will be removed after the first operation took place, but I think for now we will just leave it as is. Is it clear so far how this whole UI creation by hand without the designer works? And maybe do you think it's easier or more flexible than the designer, or would you, if given the choice, prefer to still using the graphical designer which we used in the earlier lecture? Yes, but you cannot make dynamic forms like this with the designer. Okay, good. So let's continue. So we need a way to get the selection out once it was done. So since we use this factory thing, that's a convenient solution. Class, it's too many assists. Get factory. Current data to string factor and dot one. So here I should also check whether this was successful. And if we have a factory, then could add a function, our device manager. We have forgotten the configuration. So we should not call it get factory, or we can leave it as this, but then we will add a second one. List or no covariant map get params. Okay, so we need to pass both arguments to that device later, but now we need to implement this get params as well. And let's move those further down. We'll add another helper. This will be just the labels. We could give it for simplicity to widgets. This will be just fields. But we don't need to clear both. Widgets will contain everything, but here we'll just add two fields. And now, of course, we forgot something. We have the label, we have the hint, but we need some ID for that. So over here some fields. Insert field.id, comma edit. Good. So here we'll now create a Q-variant map. A Q-variant map is just a QMap which takes a string as key and a Q-variant as argument. A Q-variant is a Qt data type which can represent a huge range of different Qt types like string, integer, byte array, another map, a list, and also a lot of internal types like a font, a brush, etc, etc. But for the typical use cases we only need like strings, integers, booleans, and that's usually it. Variants are used in different other frameworks as well. For example, the Windows API in many places uses an own version of variants, but like a very rudimentary one, so it's not comparable with the flexibility and powerfulness of a Qt variant. Yeah, so params, and then here fields begin. Insert. We can also use the square bracket operator with maps if we prefer that. e.key. And now, since we know that each of those is a line edit, it's actually quite trivial, but let's implement this already in a bit more fail-safe way. So if this equals Q, so Qt has this QObjectCast casting operator which checks the type of the object. So we can give it a type we want in the end. Of course, it only works with classes derived from QObject. And then, so here we pass a QWidget, which can be a QLineEdit. If we look inside, it's derived from QWidget. So it takes the QWidget and then it tries to cast it to LineEdit. If we would have added here something else than LineEdit, then here we would get null, and we could then else more types, and then we would repeat it like else, like is it a combo box, is it a checkbox, etc, etc. And inside there we can then already knowing which type it is, in this case just get text. For the next one, for a combo box, would be probably get current data and so on and so on. Okay, so we have params and values. So we will create add device from factory comma params, or we could use already call something on the factory like make, and then just add device which already has been created. Let's go with this approach. So we go to our devices, this thingy here, void add device, c device asterisk p device. The body of this will need to be implemented here. And then we of course need the make function on our this thing here. So virtual set make and of course each needs its own implementation. So this thing here, need to change the order because we need to be able to access the top element. Oops. And we could pass params already as an argument. So here take params. Okay. And the demo object will behave the same way. So also here need to change the order, and for good measure we will also change the order of we will also change the order in the one place which does not count that much. This here, device here, we will change the order as well. Okay, good. Let's see if it builds if we have forgotten something. Okay, it works, so we could actually go to our device, devices, device manager, put the breakpoint and see if this works correctly. Demo device 1, 2, 3, 4. Okay, and we have a device added. We have not saved the params, so usually we should then in the constructor do something with the parameters which have been passed to us. In principle, we could also made it such that we can fail the operation. We should add this functionality. That would be useful, because the parameters that you can pass, you might want to not have a combo box with only a fixed set of values, but you at the same time, so we would provide a text box as we did, but at the same time would want to restrict the amount of valid values to a limited range. For example, with a COM port, you would want to make it such that you can only use COM and then a number as your input value, but at the same time you don't want to provide like a list of all the COM ports in the system. You could do that, of course, but either you might have a situation where you cannot easily enumerate the resources, or the other scenario would be where you don't enumerate them and just I've seen this on many very old programs for different scientific hardware, where they just had the list like COM 1 through 8 and nothing else, because like on super old computers you didn't really had more COM ports. But nowadays with COM over USB you can have 20, 30, 100 COM ports even, and then this was quite limiting, because you needed to select one of the lower COM port numbers for your device instead of being able to just select the right number from the drop down. So we will quickly update this a bit. This thing will get a bool const q. This should be in the clipboard params. Okay, so we can undo this change and that change. We add here the init. For now we just return true without looking what we are doing. And here make will not take any arguments. This we need to update in here as well. Make just makes an instance, and then we see where we go from there. And here we will add the init, and here okay, that should have been everywhere. So we go to our device manager, no, this one. So the approach now would be Sternpfeil Witze ist gleich dismake, then if exclamation mark device init params tun and delete device and add device. And another thing we could do to improve the handling is to use maybe smart pointers. Starting, you could do it starting from here. So instead of pointers would be a q. I think we need to include that. Wait a second, I need to include that. Type. I don't think I have a typo then. You really need to include that thing. Finally we encountered something that was not already included before. Or maybe I had a typo. I was missing the T. Oops. Then we might not need that at the end. The nice thing about such a smart pointer is that it will automatically keep track of our object, and we will not need to delete it. Just as soon as the object goes out of scope, it will be what is it complaining? No default constructor, right. This needs to go. And here I fixed it already. Zack. Okay. Then we go to our panel here, and we don't need to delete, we can just return. And of course here this will need to be adapted to take the smart pointer instead. Okay. And now we will need to have a list of devices, and or we could also use a queue set. So the difference between a list and a set is a list is ordered. So as you add elements, they will be held in the list in the order in which you added them, while a queue set is unordered. So if you just insert elements and they will be placed inside it more or less randomly. So if you traverse the set, then the order will appear random. Of course there is an internal logic to how this deterministic disorder is maintained, but it's not something that is intelligible for a human. So I think we'll therefore use a queue list. Even though then of course removing an element from the list means to go through all the entries and looking where it is, so it's not very efficient, but we won't have a huge amount of those things. And I also think about one more improvement. We will define as a type to have to type less. Right, so with a cdevice ptr we can then now use this instead. So this ability of C++ to redefining your own types is really quite useful, as it saves a lot of typing when used correctly. Okay, so this list needs devices. So our add is actually quite simple. We just append a device to the list, and since the list exists on the object, once this object gets destroyed, then all the smart pointers for the device here will also be cleared. So this is quite nice. I think the next thing we will need will be to just get the list and add it to our the tree view. I don't think we will manage today to plot anything in the plot, but at least I think we will be able to view the device list. Okay, devices, devices. Okay, and here let's add void reload devices. So currently we don't expect anything in the device tree to change unless we add or remove something explicitly. Okay. Good. And one, let's say, very trivial method would be to just get all the entries, like just empty the tree and recreate it. The downside of this is that if we would in some scenario have to use have to update the tree in real time, so like let's say automatically on a timer, then that would make the tree flicker and it would reset the scroll bar and so on, so this would not be a good strategy. The reasonable strategy here is to really only add new elements and remove the old elements from that tree. So we can do this with a bit of code. First we create a map of the different elements with asterisk as an ID, and then q. Although actually we could use this, should also be fine. Old map. Then we will go through the tree and collect the elements which are already stored there. So for, and now I will change this to QU64. This will be most convenient. It is equals 0 is less than device tree top level count e plus plus. Okay, qt widget item per item is equals top level item from E, and this is an entry in our tree one at the root level. So this entry can have for every column a user data and a text plus an icon plus a check state plus font and many other parameters, but we only are interested in the data, so it will be using the data as the key for our map. So what was it? Data 0. So first the column and then the row, qt the row 2 QU64. So it was 2 QU long. That's the oops. That's the Q in 64 conversion, and there we assign the current element. Okay, good. Now we make we go for all the entries. Auto Davidson. Get devices. Okay, and we will need this ID that we have defined before, and this will be just the address in memory of the thing that we have. So we just need to take the raw pointer. So on the smart pointer, on the Qt smart pointer, if you have the function data, which will just give you a normal pointer to whatever is contained inside, and any pointer can be cast on the Unit64. So this gives us a unique ID, which we can then use for the for later operations. Now we will check whether we already have this item or not. So Q3. Just copy it from here. Too much typing, too long name. Is map. We can use the take command, which finds an item, takes it, and removes it. So we get it, and it at the same time gets removed from the old map. Why is it complaining? The pointer is missing. So if this is, so if this thing is null, then the entry didn't exist, and if it is null, and if it is not null, then it existed, and if you would be showing some information which would be updated in real time, then you could update it now. For now we don't have any real-time information, so we don't need to do it. And the reload devices, actually I should call it update devices, because reload sounds like it's really only used to recreate the list. Okay, so if we didn't find it, then we just make a new 3-widget item, set data 0, QT the role, value ID, and of course set text 0, now we take from the device its the device does not longer have the name. The name was on the factory. We need to fix that. And then of course the last thing to do will be to add it to our tree. So add top level item. It would be if we have many elements and optimization to store them in a list and then add them all at once with add top level items. But in this use case we don't expect to have so many entries that we will need to optimize that. And since we are removing from the map everything we encounter, we know that here the map will only contain entries which have already been removed. And since there is a connection between a tree widget and the so between the tree widget item and the tree widget it's inserted into, if we delete this, it removes itself from the list before it goes out of scope. So this way it's quite convenient. There is no manual remove function on the tree widget. So let's quickly fix the name resolution. I think the most convenient option, well, there are two options. We could either give an own variable to every device, and the other option would be to just give it a reference to the to its own factory. It's definitely useful to be able to give individual names to different devices, since we might have multiple devices of the same type, so then we would like to give them different names. I'm just thinking whether it is necessary to be able to always also get the original name, but I don't think we need that. So what we will do is will, in addition to this init function, add a actually the init can do this, could do this as well, that in addition to params it will get const string reference name. And since any device has to have a name, we can store the name here. One more change here. Need to specify the default name that comes from the factory. We ended up actually not needing the. No, we needed the IDs. No, it's fine. It's fine. Right, also here. Device get name. Okay, let's run it and try it out. Okay, we should either hide the header or write something reasonable there. Demo device. You see, it works nice. Of course, removing is not yet implemented, so this will be a homework. Should be simple enough. Good. Right, we wanted to improve the header. Set header labels. Yep. Nice. What we also can do would be can enable sorting. Set sorting enabled. So if we add multiple devices, then we can sort them alphabetically. Of course, with twists, a bit boring. So what we also should probably add is an option to give it a name from the get-go. That would be useful. Or we had an option to just rename it when we double click on it. Although double clicking might also be useful if you want to open some device property page. I guess that will need some more architectural considerations what we want to do. We could also have a button just which just says rename, and then we could rename it. Since we don't use the name anywhere, it's just for the display, it's not used to identify the device, then it can be changed at any point in time. Because you know, if we add multiple devices with the same name, then it gets a bit confusing rather fast. So it would probably be a good idea to be able to make them to look differently, especially since we have a variable now which we can update. What we also could do is we could set an edit delegate, so that we can edit something directly inside the tree. That for renaming this actually looks like a reasonable solution. So let's go with that. I just have to remember what was the proper way of setting this. Does this work for should work in the Q3 widget. I just need to check how to do that. Okay, I think we need to set a flag for that. So we edit, set flags. Take the alt flags and add a Qt item is item editable. Well, it works, but first of all we need a to use a slot to pass the changed value back, but the second issue is that it takes the double click handler, so this way we cannot use double click to open something else because we are switching for editing, so I'm not sure if this is desirable. I mean, we could also just add a context menu. That is also always a way. Where had we here? Set context menu policy. Then we need to connect this correctly. Qt custom context menu and connect 3, context menu requested, need this, comma, private slots on device menu, and then the menu will be able to have an option like rename. Oh, okay. So we need to create a menu, Q menu, and MP menu, Q action, then MP rename device. Those two need to be created ideally before, but it doesn't really make a difference since we cannot access the event before the whole thing is done. Add action, translate, rename. Oops. And we also should connect it with something. This slot. So this was called on device action. We can later have more of those menu entries, so we will discriminate them. Q action, the action is equals, and by checking what was the sender. So if action is equals MP rename device, then it's our ones, and here we need to MP device, how do I call that? Device menu, pop-up position. Okay, let's put a breakpoint here and run it. So we add the device. Position seems not correct. We can use the global position Q console position. We might need to translate the position from relative to absolute coordinates, but if we just take the position of the mouse pointer, then this one is always global, and of course if we click on this we will end up here, but as you see the breakpoint didn't set since there is nothing in the if to do. So here Q, what was it, in input dialog, no, input dialog, get text, this comma title, label, cool, normal, text, Okay, so we can get the currently selected item. It's actually not really super perfect because we only get this key-ish ID, but we don't really get we should not use this as a pointer. So for now set no, sorry, it's device ptr. Want to use smart pointers. And if data equals item data 0 qt user role to log, then break. This is something we should presumably improve, that we introduce some global IDs which we can use to not have to go through the whole list, as this is rather inefficient. If so this is not we can is null, then return. Something failed, we didn't find it. But if it worked, then we can get name. String new name. Okay, and if so, this input dialog will show us a dialog with a line edit where the preset text is entered, and we can change. Then if we press OK, it will be returned, and if we press cancel, it will return an empty string. So we check whether it's empty. We could add here an additional parameter, this OK pointer, if we want to accept a empty string as valid input. But here for the naming we don't, so it's quite easy. Now we just need to set the new name. There is no set name function, unfortunately, so we need to add it. And I think this will be enough for today. QString reference name, it's no longer a const function, and it sets the name. Right, so there is something to update. After we did this, is this still complaining? I edit not should be no set name. It exists. This is not. I think the thing is just confused. It should compile fine. Right, we move setting of name here, since it might in fact do I have a typo or what? Oops. Oh, I didn't change set to get yeah, so we add something, and then we can just rename it to 3. Et voila. Okay, I think this is enough for today. I think the homework shouldn't be too difficult. This thing here, I will upload the recording to Moodle and the project as well, and we'll see each other next week. Bye bye.